Welcome. Myself, Tariqul Islam, Assistant Professor at Photography Science and Technology University, Bangladesh. In this video, I'll discuss about environmental impacts of hydroelectric energy. Basically, hydropower is a clean and green energy source, but it has some environmental consequences. The environmental effect of hydroelectric generation is complex, requiring an examination of a hydropower plant's life cycle assessment. Firstly, I will discuss about the positive environmental impacts. Hydropower plant is the world's leading energy source. About 71% of total production of green energy and fulfill about 60% of global total power demand. Many countries have increased their renewable portfolio, including major investment in large hydropower production to meet global carbon reduction goals. Hydroelectric plants, on the other hand, have some economic lives. The simple replacement of hydroelectric generation for diesel-based thermoelectric generation appears to be a significant cost and environmental benefit. Also, the positive environmental impacts includes the presence of a dam causes turbidity to decrease, nutrients to settle, and eutrophication process to decrease downstream. Further, hydroelectric dams do not burn fossil fuel and do not emit carbon dioxide directly. Reservoirs created by hydroelectric projects frequently provide recreational opportunities. Recreational use of water system is one of the most legitimate demands of people living near lakes and reservoirs. Dams are built for water supply, irrigation, and a variety of other use, including hydropower, flood control, sediment control, and aquaculture. On the other hand, the negative environmental impacts like construction equipment along with noise, emission, and dust can have major negative impacts during the construction phase. The stressors have a detrimental impact on biodiversity, climate, population, and other environmental factors. Okay, first one is land cover change. Land cover has an effect on a variety of environmental properties from river and floodplain sedimentation rates to habitat fragmentation and wildlife populations. Increase in wetted surface from reservoir formation as well as fragmentation of the surrounding landscape by infrastructure are examples of land cover shifting. Secondly, water quality change. The key issue is the onset of eutrophication as a result of a significant rise in the average water residence time. Eutrophication is the excessive growth of aquatic plankton to the point that they obstruct the water body's intended issue. Okay, then people relocation. Another downside of hydroelectric project is the need to evacuate people who live near the reservoir. In the case of a large flooded area or in heavily populated area, this effect is highly important. Another point is outflow temperature. A reservoir's water is normally warmer in the winter and colder in summer, but due to dam, it may be changed. The temperature of the river is affected by altered temperature of the water as it flows downstream. These impacts of plant and animal life present in both the reservoir and the river, often creating environments that are unnatural to some endemic species. Then river siltation. This effect is especially important in rivers with wide catchment area, which are typically found in tropical regions and are subject to heavy rainfall, erodible soil, and high siltation process. This design can cause the reservoir to fill to capacity, reducing the ability to generate hydroelectric power and the ability to control flood. The important impact is genetic patrimony like flora and fauna loss due to habitat destruction. Large-scale flooding in catchment area may reduce local biodiversity and genetic patrimony. When a reservoir fills, terrestrial and riparian ecosystem within the impoundment are converted into lentic environments, and lotic aquatic habitats within the former channel also become lentic environment. And finally, river ecosystem fragmentation. In case of hydropower plant, dam can obstruct fish movement to spawning area, threatening to reduce reproductive number and species populations. Population size is affected largely by reduction in living space during low flow times. Okay, thank you for your patient sharing. This is all for today.